Wrong question. Everybody's saying, how did the light get from the star to the earth? They're asking the wrong question. 17 times in the Bible, it says God stretched out the heavens. Well, if he stretched out the heavens, you're asking the wrong question. It's not how did the light get from the star to here, but how did the star get from here to there? That's the question we need to be asking. The Bible says pretty clearly God made the earth first, and then he made the stars also. And he stretched, suppose he made the earth, and then he stretched out the stars from here. Adam would see the stars on day 6, and day 7, and day 8. As the star is being stretched out into place, it's going to leave behind a trail of light. So the stars could be billions of light years away today, and still have been created in the 6 days, 6,000 years ago. Russell Humphreys has a book, which I read, and I just have to say, I didn't understand it, all of it. He's really, really smart, but it's a good one on starlight and time if you want to get more on that. I don't know that I agree with his premise. I think he starts with the assumption the speed of light is a constant. Now, how do we explain that? And they get into this warped space and bent space stuff. I think it's much simpler. The speed of light's not a constant, and God made things and stretched them out into place. So, if that stretching took place, maybe that explains why we have a red shift. And we'll cover the red shift question in just a minute after the break. Okay, let's go on to the question we often get, well, what about the red shift? Doesn't that prove the universe is expanding? Or doesn't that prove the universe is billions of years old? Let me explain what they're talking about. If light shines through a prism, it breaks it up into the rainbow colors, red, orange, yellow, green, blue, indigo, violet, okay? Well, if you take starlight and shine it through a prism by putting a prism on the back of your telescope, you look at the star, the light comes through, and it gets broken up into the same red, orange, yellow, green, blue, indigo, violet. And you can kind of tell what's burning because different things burn different colors, like copper burns green. And each element produces a distinctive color. And so they can kind of tell what's in the star and how it's burning by what color of light it produces. So you can learn a lot about the stars from the light. However, as they look at the spectroscope, the colors it produces, there's little black lines in starlight indicating something's burning, a particular element's burning, but they're shifted toward the red. If you notice the center picture up there, its black lines are shifted over toward the red side, and that's called the red shift. So the question is, what would be causing this? Why would some of these stars have the black lines shifted over toward the red? Well, there are several theories about what's causing it. The most commonly accepted theory, and probably the only one that students are ever taught in school, is that the red shift is caused by what's called the Doppler effect. If you've ever been waiting at the train tracks when a train is coming, as the train's coming toward you, it is squeezing the sound waves, and so the pitch goes up. And when the train leaves you, it is stretching the sound waves, and so the pitch drops, and it goes as it goes by. That's called the Doppler effect. Who cares? Well, this happens, okay, whether the sound is moving past you or you moving past the sound, it doesn't matter. You still get this Doppler effect, the change in pitch. Well, the theory is that if a star was moving toward us, it would squeeze the light waves, giving it a blue shift, and if it is leaving us, it would give us a red shift because it would stretch the light out. That's the theory, okay? What really causes it, I don't think anybody knows for sure. This guy said there was an early sign that red shifts reliably indicate the distance to quasars. For quasars, however, the diagram shows a wide scatter in apparent brightness at every redshift. In fact, there is little correlation of brightness to redshift at all. Either quasars come in an extremely wide range of intrinsic luminosities, or, as most people believe, or their redshifts do not indicate distance. I don't think anybody knows for sure what's causing the redshift, but you certainly can't tell the distance to a star based on the redshift, and that's exactly what they try to do. They look at stars and say, oh, that one's redshifted more. That must be, 10.5 billion light years away instead of 10.2 or something. They make up an awful lot of imagination stuff over just a real little bit of science, in my opinion. This fellow said in Sky and Telescope magazine, thus, for us, the only conclusion that can be drawn is that at least some quasars are relatively nearby, and a large fraction of their redshift is due to something other than expansion of the universe. Basically, he's saying, we're not sure exactly what's causing the redshift. It might be that they're nearby. There's a good book you can get. I highly recommend this one called The Evolution Cruncher. It's a 900-page book, and it's like $5. He's got a whole section in here on page 52 about the evolution, about the red shift and the Doppler effect and what causes it. Got some really good stuff in these you can give out to every high school kid you know. But there's a good section in there about the red shift, what's causing it. This article says quasars with enormous redshift was found embedded in a nearby spiral galaxy with a far lower redshift. Now, how can one star be inside of another star and they're giving you two different redshifts if this indicates distance? If they're the same, if a quasar is inside a galaxy, they should both give you the same redshift, both be the same distance away. But they admitted they found this quasar inside of a galaxy that had different redshifts, but yet they're obviously the same distance away. So they said, according to the standard Big Bang view of the universe, the objects we call quasars are generally supposed to be at the very edge of the visible universe. They're supposed to be superluminous black holes with 1 million or 100 million times more mass than our sun, surrounded by a disk of matter, or material. Some of the material falls into the black hole, causing the emission of huge amounts of energy. There's a big article when they discovered this cosmic discovery. Discovery poses cosmic puzzle. Can a distant quasar live within a nearby galaxy? This really created a problem. How on earth can we have these two objects that are different distances at the same location? Well, it's not a problem if you realize that you can't trust the redshift to measure the distance. But they're so anxious to say the universe is billions of light years across, and it probably is, and then use that as evidence to say, therefore, it's billions of years old. And that's why this all becomes a problem for them. If they would just accept the Bible, it wouldn't be a problem at all. This article said, quasar with enormous redshift found embedded in nearby spiral galaxy with far lower redshift. Unsolvable riddle for Big Bang astronomy. I agree. If you believe the Big Bang theory, that is an unsolvable problem. Science News ran an article said, another set of observations indicates that the universe appears to be 8.4 to 10.6 billion years old. The new work relied on Hubble Space Telescope to obtain distance to faraway galaxies. The team led by Tanver, the University of Cambridge in England, used a two-step method to estimate the Hubble constant. Now stop and think about that. How many of you have had algebra before? You had algebra? You have variables in your equation, okay? Well, if one variable times a constant, if one constant changes, that's going to change your whole answer. So most of this distance stuff they're doing with stars is based on what they call the Hubble constant. But they don't even know what that is. The Hubble constant is estimated. That's going to radically affect your outcome of your equation. So is the universe 8.4 billion years old, or is it 10.6, or is it, when I debated Hugh Ross at Reasons to Believe, he said it's 17.42 billion years old. 17.42. How do you know that? Some textbooks say 18, some say 20, some say 12. The numbers range all over the scale. The fact is, they don't know. They're making up numbers, purely making them up. The article goes on to say you have to be very careful about drawing conclusions because of the Hubble constant. Measurements have huge systematic errors. I like this article. Came out in Discover magazine a couple years ago. Astronomers believed the Veil, one of the best studied supernova remnants, was 2,500 light years away and 18,000 years old. They were quite wrong. In fact, the Veil is only 1,500 light years away and 5,000 years old. So here just 4 years ago, they're discovering they got radically wrong numbers. How do you know any of the numbers they're telling us are right? I think we should say, look, until somebody's proven the Bible wrong, I'm going to believe it. Instead of saying, well, the scientists are saying it's wrong, so therefore we must believe the scientists. Don't go along with that. Even the nearest Cephids, a Cephid variable, are so remote, it's difficult to determine their absolute distance with any great accuracy. All large distances in astronomical literature are subject to an error of perhaps 10% from this cause alone. There are lots of different things that can cause errors in these measurements. We talked about the triangulation, measuring with trigonometry. You got incredible errors built into that. The numbers are just so big. The distances are so large you can't do it. They say we know that faintness, that's how bright the star is, arises from two causes, distance and absorbing matter in space. That's what's happening. They look at a star and say, wow, we know that one is, 4 billion light years away. And look at that one over there. That one's only half as bright. So it must be, 8 billion light years away. They use the inverse square law. And that's all logical if there's nothing in between absorbing the light or scattering the light. Just because a star is dimmer doesn't necessarily mean it's farther. It might be something's in between, a dust cloud. Outer space is full of all kinds of stuff. Anyway, the guy admits it's not generally possible to apportion it between the two. There's more about Halton Hart and what happened to him, the persecution that happened to him because he dared to question the redshift. All he did was expose the problems with it. He said, guys, that redshift has problems. Oh, well, then you're fired and you get out of here and don't you ever come back, until you repent. Because you just don't question some things. They're sacred. The Bible says in